पर्दे में रहने दो पर्दा ना उठा।
तो आज से हमारे कॉलेज में स्टार्ट है ओपन हाउस 2 जनवरी to 5 January and I'm the volunteer of structural department and I'm going for it and let's explore. So continue the video.
Sunshine, I think I found it now. What I've been looking for, isn't it beautiful? It's got my head all up in the clouds. I think I found it now. Everything I want might be a miracle. No, I'm never coming.
Hello everyone, this is Tejas. First we welcome you all to our department. Our department is Structural Engineering Department of IIT Madras. Here we have 2 labs, Statics Lab and Dynamics Lab. You all can explore new technologies, new equipments for testing the various equipment of our components of our civil engineering structure. You also can explore some models. We have some models like concrete models, some bridges model. We also have some games to have some great entertainment. So we request you all, please come and explore our lab. Thank you.
Sunshine, I got sunshine, I got sunshine. I gotta let you know, it's so incredible. I'm finally letting go. Up, up and away, yeah we go. I found my flow, right on time, and now I know what it feels like to shine like gold.
So actually I am doing a steel column buckling and Adil is the main guy in this program. Everything thanks to happens is during an earthquake. So this is the moment you can see, this is a depiction of what happens inside the water tank. So during the earthquake you can see the movement of water. So now in order to prevent this happening, we have tried to isolate this base from the ground of the earth. So what happens when we've isolated the ground, you can see the movement now, what's happening. The movement has considerably reduced. Yes, yes. So you can see it in the picture over here. We have isolated the building. This is the building and this is the foundation of the building. We have isolated the building and we have put in a fiber reinforced, either we can, not fiber reinforced, sorry, I'm telling it can be rubber or we can also put steel here. So we have isolated the building from the ground. When we isolate it, so whatever happens here, because of, so basically earthquake, when there is an earthquake, the damage happens because the building is so rigid that it cannot move with the earth. So when we provide this bearing, now as the earth moves, building also moves along with the earth. So when that's happening, the collapsing of the building can be reduced, and that collapsing will not happen. So when that is happening, see if here, when we do not provide this isolation, the building moves because building is not equipped to move with the earth. So because of inertia, buildings try to stay in its position, but when the earth is moving away, so building tries to sway. When there is swaying, there is breakage of pipes, there is breakage of windows, there is loss happening to the building. There are people here, and people also cannot come out of the building because earthquake happens for a very few seconds. Yes. Buildings are also using this. Now we have come up with a thing where buildings, high-rise buildings, because they're very much prone and the damage is also very much high for a high-rise building. Yeah, we are trying to use this now. So this is the method, and one such demonstration can be seen over there where you can see a curtain of steel. You can see it over there. That is an origami structure. So origami structures can also be. Yeah, this is what we have provided. This is in case of a basement where we have provided. Yeah, we can also provide. This is basically what we have done is isolating. So this is done in the foundation work also, where the foundation of the building is isolated from the superstructure. So we can, when you provide that, the movement was so low that there is very minimal damage to the building. So that is how, yeah. This is one of the methods which we have come up to prevent the damage that is happening because of an earthquake. Thank you.
I got sunshine. I got sunshine. I got sunshine. I gotta let you know. I got
Give clue, the other guys has to find. So who will give clues? One has to give clue.
Fun game है क्या?
Yeah, it will be fun. Like words like bridge, easy words. Come on, around. Someone and come now. Okay, come. So the other guys can go there. So 1 minute la how much? A guy found 13. So 1 minute how much you will find? That's the game. Ready? 1, 2, 3, start. Okay.
అంటే ఇలాంటివి ఉంటాయి. మ్యాథ్స్ సాల్వింగ్ అంతే క్యాలిక్యులేటర్ చెప్పండి ఈ కోర్స్ ఆడతారు అటు బయట రాకెట్ పంపిస్తారు శాటిలైట్
4.
ఫ్రాన్స్ లో అది ఫేమస్ 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 టవర్ ఫేమస్ టవర్
5.
స్టార్ట్ చూడడానికి చెప్పండి
6.
బీచ్ దగ్గర షిప్
Okay. 7 points. So not everyone can throw since there are lot of people. We'll give out of you guys 3 guys can throw. Your points can be double. You will be in leaderboard. So you choose only 3 people. Go 3. Line left. You should throw from here. Ready? Next 2. Oh, so close. So if you throw now, you can, your score is 14. Okay, thanks. Okay. Okay.
I got sunshine. I got sunshine. I got sunshine. 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 I think I found it now. What I've been looking for. Isn't it beautiful? It's got my head all up in the clouds. I think I found it now. Everything I want might be a miracle. I know I'm never coming down. I don't gotta worry about a single thing. I can feel the light coming down on me. Sunshine on my face. I got sunshine on my face. I don't gotta care in the world right now. Higher than the ceiling, breaking through the clouds. Sunshine. Sunshine.
Concrete structure, if we compress it, it will won't break. If you press a stone, it will break. It will have much strength, right? If you elongate like this, it will break. So steel in this direction, if you press in this direction, it will break. In this direction, it will have strength. Okay. So this is having compressed this strength. The steel has this strength. So by mixing this, we can have a greater strength. Okay. And this is a type of 3D printing. Nowadays, they construct pouring a concrete in the that will take it 20 days of time. This will take a 15 to 30 days of time to build a column or a boundary wall. It will be very safe and economically. Less than this cost it will be. And we can vary with this thickness also. In this we cannot vary. This will be a specified size and we will be designing depend upon our requirement and building height. Okay, this is the column. We have seen now column structure will be like this. This is the framework. This is the steel is provided in it. Okay, this is the frame which is used to hold the column. This longitudinal reinforcement will be telling the steel here. Yeah. And this is the roof. This is a type of, in our in our home we will be having slab with this thickness. If we go to G plus 3 or G plus 7 at the top floor, there will be no much loads, right? In first floor, second floor we will be working and our furniture will be there, so that load will carry by that beam, so that will be having this much strength. So by going up at the top of our building, there will be no live load and we will be not walking much, and there will be no furniture. So at what place we need load, that place will be having this structure. Without that load carrying will decrease it. In this the concrete amount of cement concrete will be reduced. Okay, so this is a type of this is type of roof. Okay, you can visit the thank you.
I don't gotta worry about a single thing. I can feel the light coming down on me. Sunshine on my face. I got sunshine on my face. I don't got a care in the world right now. Higher than the ceiling, breaking through the clouds. Sunshine on my face. I got sunshine on my face.
And concrete, cement, correct. So your FRP can be completely used to replace cement and concrete. So these are the raw materials. This is Revong and this is carbon strands. So these, when we combine, we can make fabrics, and these can be molded using resins to make sheets or deck like this. Okay, so these can completely replace your concrete or steel in your structures. So the main advantage of this is you have very lesser weight. The density of this is like 1800 kilogram per meter cube. So it has very lesser weight than compared to steel. Plus it has more strength. Plus the main advantage is it is corrosion free your entire life. So once you set it, you don't have to worry about corrosion or your yearly maintenance charges for your entire life. Then currently this is not being used in India as of now. But in the US or the Europe, this flat or this deck is used in bridges, aircrafts or ships, and they provide like lesser weight, so you could make like larger ships, larger aircraft. You could place more seats in those, so that like plays an economical role towards it. And this helmet is another example where this can be used. So this is like a typical military helmet. So like the most important use of it is to withstand a bullet from rifles. This is like you can weight. It's like 2.3 kgs in weight. It's quite heavy. So currently they are trying to use these fabrics to reduce the weight of this. Yeah. These are the examples where this can be used. Any part. All of them can be replaced. Yes. So like we have RCC, reinforced cement concrete, in which you have concrete and your steel. So instead of concrete, you'll use resins, and your steel, except for steel, you'll use these fibers. So that will play the role. You can use it in any part, or also you can like use the composites made like partially. You can use them, but they are like very high in cost, so they're currently not in use because of the cost thing. And people are not aware of it. That's why.
How will you join this? By starting, how will you join this?
Adhesives can be used to join.
Only resins.
Adhesives and all. Yeah. These are like molded after using resins and stuff. Yeah, these along with resins are combined like in factories to make this. It is fiber reinforced polymer. G is for glass and C is for carbon. So these are like in metals you have alloys. So similar kind of thing.
But now as an innovation, 3D printing is also building.
Yeah.
3D printing. How this is
This has more strength and less weight than that, but the same thing. The cost is high.
See, 3D printing is a method to manufacture, and this is the composite materials. We are talking about specific materials here. These materials are used in various applications, such as in defense. Defense, as he mentioned, that they are being used in aircrafts, navy as ships, warships, submarines. Like in army, they are being used as in ballistic helmets and bulletproof vest and all. Because the main advantage of these material is they are very light in weight. If you compare steel and these materials, their weight will be three times less. But only factor is their cost will be maybe 3 times or 2 times. So this is the only factor disadvantage. Otherwise, if you see the advantages, the strength, weight, it is considerably good.
The benefit to cost ratio is very good, but that's the thing. The initial investment is high.
And steel and all, they get corroded. Like if you use these rebars, they won't get corroded. You can use them for 100 years, 200 years, they won't get corroded. Your structural, the life of structure will increase many folds. Thank you.
Sunshine, I gotta let you know, it's so incredible. I'm finally letting go. Up and away, yeah, we go. I found my flow right on time, and now I know what it feels like to shine like gold. Up and away, yeah, we go. I don't gotta worry about a single thing. I can feel the light coming down on me. Sunshine on my face, I got sunshine on my face. I don't got a care in the world right now. Higher than the ceiling, breaking through the clouds. Sunshine on my face, I got sunshine on my face. Yeah, I got sunshine. I got sunshine. I got sunshine.
Yes, sir.
Yeah, sure. No, I'll just explain this. We are doing masters. No, I'm doing my PhD. That is PhD. So I'm working with Professor So my thesis tentative title research topic is on auto behavior and design of this one, the double-decker bridges. So I just want to explain the mechanism. I hope you know the bridges.
Bridges is a different area, so you can just
So the main the bridge model which I'm going to explain is bowstring bridge model. So here what is happening is the physics behind the bridge is the bow and the arrow. It's just simple because when you just try to compress an arch, it just tries to move outward. So you're just restricting the outward displacement of this arch, and by using a string or a tie. Now what is happening here is, what is the use of restricting this forces? Because the large amount of forces is being transferred to the supports if you just leave this arch like that, and there would be an instability caused because you're just pushing the arch. The more amount of load is getting onto the arch, you're just pushing the arch outward. Yes. So I just want the main thing about this tied arch bridge is you're getting a tie, and from this tie the load is getting transferred through the hangers, and from again it's getting transferred to the arch. Because whenever the load is coming onto this hanger or the tie, so the tie is getting is transferring the load to this hanger, because the more amount of deflection, if there is no support here, if you just pull the string, so there will be a more deflection of the string, right? So to control the deflection of the string, we are using the hangers, and from the hangers they are in tension, and they are pulling this bow down as if shown there. So from there the compression is is transferred to the supports, and now I don't need to design the supports for that much compression or that much outward thrust. So what is happening? It's again self-balanced with the help of the tie. So there's an internal load must be created, which reduces the reactions with the supports. So that is the main difference between an arch bridge and a tied arch bridge.
self-equilibrium.
Yes.
Like the tied are actually the vertical reaction should be green.
Yes.
Horizontally, you do not restrain the.
Yeah. Horizontally.
I got sunshine. I got sunshine. I got sunshine. 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 Sunshine.